Hey folks, welcome back to another video. Today we're looking at question 2064, minimize maximum of products distributed to any store. The way that we solve this problem is by using binary search. And why are we using binary search for this problem? Basically, the reason why we're using binary search is because we want to get the minimum number of the maximum products that can be distributed to each and every store, right? And we know what the upper limits and the lower limits are. The lower limit is basically 0, where we don't assign any products to that given store. But the upper limit is the maximum that we see in the quantities area. But because we want to minimize it, we'll play around with these limits and keep using binary search to get to the lowest possible value, thereby accomplishing what the problem wants us to do. So let's get started. Binary search, the structure itself is very easy, so let's write that out. So we have int, we have the left pointer, we set that up to be 0. Int right, we'll set that up to be 0 as well, just initially. But we know that we have to assign right to the maximum quantity that we see in the quantities area. So int q in quantities, if our we can actually make this a one-liner. So R would be equal to math.max of Q and R. And once that's done, we have the binary loop where basically while L is less than R, we calculate the midpoint. So the midpoint would be equal to left plus right divided by 2. Right, and then we have some sort of a helper method which allows us to compute whether this quantity is possible or not. So for now, let's just call it helper. And we can decide what goes into it. But if this passes, like let's say this passes like a Boolean value and this is true, that means that quantity is possible and we can try to reduce it. So that would mean that right would be equal to mid. If this is not possible, that means we need to increase increase the values that with which we are playing. So left would be equal to mid plus 1. And in the end, because we want to return the minimum value, we would return left value. Okay, so this is basically the skeleton. So let's write the helper method. So for the helper, what do we need? We need the current quantity that we're playing with. So the first thing that we need to pass is mid, and let's call that int current quantity. So int q, and what are the other things that we need? We need the number of stores, which is n, and so this will be like, yeah, we can just pause this as n as well. And then we need the quantities area as well, so we'll grab that as well. Okay, amazing. What do we need right after that? So basically we need to go through all of the quantities in the array and try to assign them to each number of stores, right? So int index, let's just call, we start all the way from 0, and int current quantity that you're playing around with would be equal to quantities of index, right? So and this has to get assigned to every single store, right? So for int I equals 0, I less than n, increment I. So if the current assigned quantity, Q, actually, yeah, the current quantity, if it is later less than or equal to, let's call this assigned quantity, assigned Q. If it is less than or equal to assigned quantity, that means we can assign it to the current store and thereby increase the index. If not, we basically subtract the current quantity by the assigned index, which basically means, hey, like assign this quantity to the given store, but like there's still quantity that has to be assigned. So move forward with it. But in this if loop, there are a couple of things that we have to check. So if index is equal to quantities.length, which basically means that it has reached all the way till the end, it means that it has been, the quantities have been assigned all the way till the end, and this means that the assigned quantity works, and you would return true. Else, you just need to update the value of the current quantity that you're playing around with. So current quantity would be equal to quantities.index. Awesome. So if even after all of this, nothing has been returned, you just return false in the end. Okay, let's try compiling this. Right, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. The time complexity of the entire solution is n log n because it is a binary search that we are using for this problem. Space complexity is of 1 since we're not using any additional space, only constant space to figure out how to solve this problem. Amazing. So that's the solution. If you have any questions, please let me know in the comments below. And don't forget to subscribe to the channel and like the video. I really appreciate that. It definitely keeps me motivated to keep going. Thanks so much, and I'll see you folks soon. Peace.